Hi and welcome for the second part of 2 videos about gas. The first video I taught you about the types of gas, which is they are natural gas, propane and butane. On this video we're talking about their properties, which is they are the calorific value, the relative density, the combustion temperature. Now then, so the very first thing, or the very first point I want you to understand is the calorific value. So the calorific value is the amount of heat, energy, a substance releases when it burns. Okay, so I got a table here, which is I'm going to talk to you about. I hope you can see it. Let's have a look. Here we go. Right. Natural gas, right, which comes into your boiler, has a relative density less than 1. As you know, anything less than 1, you will float. Everything over 1, we will sink to the floor. Okay, so which means is, because of the relative density is 0.58, okay, so that means you will disappear into the air because of the relative density, okay, and it's less than 1. Also, as you can see, the calorific value is 38.5 megajoules per cubic meter. So now that means the calorific value gives us the heat. So the flame temperature of natural gas is around about 1930, as you can see this, degrees. Now to burn and to give the complete combustion, it also needs oxygen, right? So this is why I'm going to referring you to the very first table we done on the first video, right? So let me bring the table back. Can you see the table now? The gas-air ratio, 20% of oxygen. So for every square meter of natural gas, the natural gas requires 10 cubic meters of air to give the correct air ratio. So that is the table. Now I'm explaining a lot better for you to understand. I give you the air ratio earlier. Now we come across these all the time. Now let's look into the propane. So the propane, as you can see from here, you got a relative density over than 1 is 1.78. Okay, so which means is you will go to the floor. You will go straight to the floor. You will sink, right? So because of that, the calorific value, right, is got 95 megajoules per cubic meter. Okay, so one thing you need to remember, because it's so go down to the floor, you need to remember how, if you're using the in a cellar or closer to the drains, make sure you use it properly, because it's got a very high relative density. Also, when you store it, so make sure you store it properly outside in a well ventilated area, away from combustion materials, in case if there is a leak it can disappear into the air. Okay, so as you can see, the temperature is 1980 degrees. All right, so in this case, per every cubic meter of propane it requires 25 cubic meters of air. Remember our very first table. Okay, so propane 1 per 25, right? Now then, let's go talk about butane, right? So butane, like propane, it's got a very high relative density, and now this is a lot greater, right? So because it's 2, so the relative density is so great it goes to the floor quite quick. All right, now the same consideration applies when you store it and when you use it. So make sure you put it outside, upright, and away from flammables, and on a well ventilated area. Now then, as you can see, you go 121.5 megajoules per cubic meter of calorific value, right? So the temperature is also quite high, so it's 1996 degrees. So that's why we don't use that for soldering. It's too hot for soldering. Okay, so which means is, right, generally speaking, only come across of butane for barbecue situation when the heat is required, right? So per every cubic meter of butane, we need 30 cubic meters of air. So that's what our air ratio. Okay, so there is one more gas, and we used to use these quite a lot in the industry, which is acetylene for lead welding. Okay, but lead welding is no longer gone part of our qualification, so acetylene is a way hotter than any other gas. All right, so you might be come across for brazing, right? So now you know the calorific value, you know the relative density of both gases, and you know the combustion temperature. All right, so one thing you need to remember: always refer to the tables. Some tables in certain books are coming in varying in the amounts of the calorific values of the gas. It only depends also about pressure and volume. So this is something you need to refer to, okay, and to take in consideration when you read. Make sure you understand what you are about to read. I hope you find these two videos helpful and informative, and I'll see you soon.